Hello students, welcome back to my channel EdTech Guruji, and we are doing this series Vigyan Ka Gyan especially for 10th standard students. So we were doing the numericals of gravitation, and this is the second part. I hope that you have watched the first part already. If not, the link is in the description. Have a look at it. Okay. So moving ahead, today we will deal with one of the concepts and the numerical related to it. It's a high order thinking question, so pay attention and enjoy the class. So the question is, prove that if a body is thrown vertically upward, the time of ascent is equal to the time of descent. Okay, so let us see. When the body is going in upward direction, that is for upward motion, let the time of ascent is t1. Using the first equation of motion, we get v1 is equal to u1 plus gt1, where v1 is the final velocity when the body reaches to a certain height, u1 is its initial velocity by which it was thrown in upward direction, and the time is, as we have written, time of ascent. Okay, now in this case we need to understand the body will show retardation as it goes upward. The velocity will become less. Okay, the body will become slow and finally will stop after reaching a certain height. So its final velocity will become 0 and the acceleration hence will be negative because it is retarding. Okay, now if I substitute the value in equation number 1, I get 0 is equal to u1 minus gt1. Okay, and from this it is very clear that t1 is equal to u1 upon g. So this is my equation number 3, a very important equation. So the time of ascent can be calculated by the values of initial velocity divided by acceleration due to gravity. Okay, now when we go to the next part of it, that is when we are calculating the time of descent. Okay, we need to understand that now the body is coming down after it has reached a certain height. Okay, so its initial velocity now will be same as the final velocity of the first case, and as it is falling under the influence of gravity, the acceleration this time will be equal to the retardation in the previous case. So let us have a look at it. So for the downward motion, let the time of descent is t2. Using the first equation of motion, we get v2 is equal to u2 plus gt2. v2 is the final velocity of descent. Okay, u2 is the initial velocity when it starts coming down. Okay, so as the body will show acceleration equal to the retardation in previous case and has stopped at a certain height, so it will start from rest. So we understand that u2 is 0 and v2 is going to be equal to u1. How? I have given the condition that acceleration is going to be same as retardation. Now what is acceleration? It is the rate of change of velocity. Okay, and we have also understood that the initial velocity now will be same as the final velocity of the first case. So if your acceleration is same, okay, and one of the velocities is same as of the previous, then by default the second value of velocity will also have to be same. So if the initial velocity is same as the final velocity of the previous case, then the final velocity of this case will be equal to the initial velocity of the previous case. So if I substitute all the values, I get the equation as u1 is equal to 0 plus gt2, and clearly I can see that from here t2 is nothing but u1 by g. If I compare equation number 3 and equation number 6, I get t1 is equal to t2, hence proved that the time of ascent is equal to time of descent. That is, t1 is equal to t2. So I'm sure that this is very clear to you. An important conclusion. Okay, and now let us move ahead to the problem related to it. So what is the numerical? An object thrown vertically upwards reaches a height of 500 meter. What was its initial velocity? How long will the object take to come back to the earth? Okay, and there is a condition given to us. We can assume in this problem that acceleration due to gravity is 10 meter per second square. See, by default we take 9.8 meter per second square always, but here because it is given to us, we can take it as 10 meter per second square. But be careful, you cannot take it as a default acceleration due to gravity. By default, if nothing is given, we will always take it to be as 9.8 meter per second square. Okay, so let us see what is given in this question first of all. Okay, so first we make a note of it, what is given to us. So what is given here is number 1 is the height it reaches to. The height will act as the displacement. Okay, so the body reaches to a height of 500 meter, and acceleration due to gravity is given to assumed as 10 meter per second square. 10 meter per second square. Okay, what we have to find, what we have to calculate. Okay, let us see that. We have to calculate total time. Let the total time be t. Time for the body to come back to the earth. So let us begin with the solution. Okay. First of all, we need to find the initial velocity. So now displacement is given to you. Okay, we know that as the body is going upward, its final velocity is going to be 0. So we can calculate the initial velocity using third equation of motion. Okay, so using third equation of motion, we conclude that v square is equal to u square, okay, plus 2gs. Now two things here. Number one, v is equal to 0, and second thing, the body will show retardation. What do I mean to say by retardation? That this acceleration is going to be negative, so this plus will become minus. So substituting these values, I get 0 is equal to u square minus 2gs, which implies that u square is equal to 2gs, okay, which also means that u square is equal to 2 into 10 into 500. सारे values put कर दिए. So this becomes 2 into 500 into 10 is 10,000. 10,000 मतलब 10 raised to 4. So therefore u is equal to square root of 10,000. Okay, 10 raised to 4 का square root क्या होगा? 10 raised to 2. That means 100 meter per second. So this is, guys, my initial velocity. Okay, now to find time. Okay, now to find time. Initial velocity हो गया अपना clear. ठीक है ना. Initial velocity कितना है अपना? Initial velocity आ रहा है 100 meter per second. अब for time we use first equation of motion. Okay, so using first equation of motion. Okay, so what is first equation of motion? V is equal to u plus gt. Okay, again here v is equal to 0 and the body is showing retardation. Again, when I am saying it is showing retardation, matlab ye plus ho jayega minus. So this becomes 0 is equal to u minus gt. Okay, it implies that u is equal to gt. So therefore, let us say this is time of ascent. Okay, when the body is going up. So this is going to be equal to u by g. U is 100, g is 10, 0 से 0 cancel. So ये कितना आया? 10 seconds. Okay. Now let the time of descent is td. Okay, so we just proved that td is equal to time of ascent. Okay, that is going to be equal to 10 seconds. So मेरा td भी कितना आ गया? 10 seconds. Therefore total time, okay, total time अगर हमारा t है तो this t is going to be equal to ta plus td. So that is equal to 10 plus 10. Hence it is equal to 20 seconds. Okay, so our time, okay, which the body will take to come back to earth is 20 seconds. Now we can quickly write the statement. Okay, so what is our statement? Statement is therefore initial velocity of the body was 100 meter per second, full stop. And the second question is, it will take 20 seconds. Okay, it will take 20 seconds to come back to earth. This is our statement. So I hope that the proof and this numerical is very clear to you. So students, for more problems and the other related topics of 10th standard, stay tuned to the channel, subscribe with the channel, okay, and also share it with as many students as possible and in your connect, so that they can also be benefited with these videos. Thank you. Signing off.